Hello friends. So today we will discuss types of error. Types of error. Types of errors. Types of errors. In previous lecture we have understood what is the meaning of error. Error is what? Error is the difference between true value or true value means what? Actual value and measured value This is called what? Error. This is called error. True value and measured value. Okay. Now, first type, or before we discuss type, we will see arithmetic mean. Arithmetic mean. Or this is called true value also. This is called true value. True value or actual value. Actual value. Okay. Now, what is this? So what we will do, if you want to measure a length of a rod, okay, or anything, any measurement, it can be any physical quantity, it may be fundamental, it may be derived, anything you can have. So, we will take lot many readings. In the previous lecture also I told you how to find the true value. You take number of readings and take the average of that. Suppose A1, A2, A3, like this, n number of reading we have taken. A1 to AN. Okay. So you calculate A mean, like A means average. Okay. So A1 plus A2 plus A3 plus you add all the readings and you divide it by number of reading. Okay. So it is the average. This is called A mean, and this we will treat as a true value. This we can consider as this arithmetic mean is considered as true value. Okay. Now this can be represented like this. A mean is equal to 1 upon n. Okay, this 1 upon n I will write on this side. Then I is equal to 1 to n ai. What is the meaning of this? Meaning of this is 1 upon n. Okay, so this is a summation symbol. Means I changes from 1 to n. So first you take I is equal to 1. So ai, this is a summation symbol, plus then a2, I is equal to 2. So a2 plus I is equal to 3. A3 plus like this, I is equal to n. So in this way, addition of all this divided by n, you will get A mean. So in this way also, this can be described. Got it? This is what, and this arithmetic mean is considered as a true value. Once you know the true value of that measurement or any physical quantity, then in further measurement, whatever error occurs in the measurement, that you can calculate. Okay, so you note down this. Based on this, we will discuss types of error. Okay, types of errors. Okay, now, so first is absolute error. Absolute error. What is absolute error? Absolute error. Absolute error means what? Suppose in a measurement, number of reading taken. Suppose 5, 10 something. Let us assume 5 readings are taken. So let us say A1, A2, A3, A4, A5 like this. So absolute error can be calculated in each reading. let us say absolute error in A1 is for example what we can note like this, A1 absolute. A1 absolute means absolute error in the first measurement is given as this mean means true value minus that reading A1, and its magnitude, positive value. Subtraction of A mean minus that reading and its mod. That is the absolute error in this measurement. So in this way, you can calculate absolute error in each reading. And always remember, as this is the mod, absolute error is always positive. It is always positive, because this is a mod. So if you want to write, you can write in a set of readings of a measurement, in a measurement of a physical quantity the difference between mean value means arithmetic mean value and measured value is called absolute error. Okay, is called absolute error. So absolute error, like this you can write, absolute error is mean, A mean. Actually here I have to add, in a set of reading, in a measurement of physical quantity, the difference between magnitude of difference. Here I should add magnitude of the difference between mean value and measured value is called absolute error. So A mean minus that particular reading and its small. Okay, in this way we can write mathematical expression for absolute error. Okay, so for this we can write absolute error in 2 is mod of A mean minus A2. So like this you can write for this absolute error in A3, absolute is A mean minus A3. So like this for all readings we can write. And how this A mean can be calculated? If 5 readings are taken, this will be what? A1 plus A2 plus A3 plus A4 plus A5 divided by 5. That will be the A mean. That is the arithmetic mean, true value. True value is calculated like this. I told you in the previous lecture also, no instrument is perfect, no operator or human being is perfect. And so to measure the correct true value, but by taking number of readings and averaging that, we can get a true value, or we can consider it as a true value. Okay, and like this errors you can calculate. Simple, understood, no problem in this. Okay, so you note down this so that you will see another type of error. Okay, you can pause the video and you can note down. So actually I am going very slowly, so simultaneously with me we can write. Another is what? Mean absolute error. Mean absolute error. What is mean absolute error? Absolute error we know is mean. Is means average of that. So we have calculated lot many absolute errors in a reading. So 5 absolute error we have got. So 5 absolute error, addition of all this divided by 5, divided by number of reading will be what? Will be the mean absolute error. Okay, so it is the average of all absolute errors in a set of readings of a physical quantity. And as absolute error is always positive, this will be also positive. So mean absolute error is equal to what? Summation of all absolute errors. Summation of all absolute error divided by number of readings. Divided by number of readings. Okay? Simple? So, suppose 5 readings are taken. You add all those 5 readings divided by 5, you will get A mean. Then, from A mean, you subtract individual readings, you will get individual, and you take the mod of that, magnitude of that, you will get individual absolute error. You add all those absolute error and divide it by number of reading 5 here for example, you will get mean absolute error. Okay, note down this. We'll see. Next part is random error. Not random error. We'll see another type. That random error and systematic error also we have to discuss. You note down this first. Can I erase this? Relative error. So what is relative error? So relative error is relative error. Relative error is delta A mean or mean error. Mean, or I will write in words, relative error is equal to mean absolute error divided by mean value or arithmetic mean. Mean value means true value or actual value or arithmetic mean. Okay, so this absolute error we know how to calculate. Now divided by mean value, this mean value is a relative error. So we can write this as a relative error. So this will be what? Delta R. Let us say that is the mean value, mean error divided by actual value, that is R. So this is what? A relative error. Okay. Then we will have percentage error. Percentage error. Okay. So what is percentage error? The relative error expressed in percentage is called percentage error. Percentage error means what? This relative error. Percentage error means what? This relative error into 100. This error is also called fractional error. This is also called what? Fractional error. You will get in some point 0.1 something, okay, or 0.01 something. So 0.01 into 100 will be the percentage error. 1%, 2%. Suppose relative error is 0.01. Fraction error, relative error into 100. 0.01 into 100. This is a percentage error. Means what you will get? This is a 1% error. Okay. So in this way, we can have all these types of error. Okay. Now, before we go for the error propagation, error in addition, error in subtraction, this we have seen for individual physical quantity, one physical quantity. It may be length, it may be mass, it may be velocity, it may be anything. Okay. For one physical quantity, this we have learned. But it may happen that suppose area is equal to length into length. So individual error will be there in this. Individual error in this will be there. Okay, area will be what? Suppose we will say this is a rectangle. Suppose rectangle. So this is A and this is B. So A into B is the area. So error in A and error in B will be there. So there will be this error will be propagated in the calculation of area. Okay, so that we have to see. So that will be the error in the what you can say, multiplication. So like this, you will have some physical quantities can be the addition of 2. Some physical quantities can be the addition of 2 fundamental or 2 derived quantities. Some physical quantity may be the division of some any 2 other fundamental or derived quantity. So individual error will be propagated. Okay, that we will see. But before that, I want to tell you the cause of this error. Or based on that also, there are 2 types of errors: systematic error and random error. That we will discuss first, and then we will go for error propagation. Okay, clear? Can I erase this? Based on cause of the error, we can have another types of error. Types of errors based on cause or method of measurement. Okay, so one is systematic error. Okay, and another is random error. Okay, what is systematic error? Systematic error. What is systematic error? Now look, in this cause of error is known. Cause of error is known. Means what? Suppose this is one glass. Okay? In this some water is filled. Okay, so this is the level of water, we can say. This is the level of water. So I want to measure the height of water column here. I want to measure the height of this water column. So what is the method? Method is we have to look in this direction. We have to set like this. And in this direction we have to observe. And here one scale is kept. Here. Okay, here calibration is there. 1, 2, 3, 4. Suppose this reading is 5.8 centimeter. This reading is 5.8 centimeter. But some person may look in this direction like this. Glass is kept. The water level is this much, and he will look in this direction like this. So he may observe this reading. Let us say 5.7 centimeter. Another person will look like this, height is less. So he may look like this. So this is what? He will get this reading. So this will be what? 5.9 centimeter. So this is the error. Okay, but somebody is observing how they are taking reading. He knows the cause of this error in this. Okay, what is the error in this? Actual value is 5.8. So error in this measurement is what? 5.8 minus 5.7. So this is a 0.1 centimeter error. In this reading, in E2 or measurement E2, we can say notation you can write anything. 5.8 minus 5.9. So this will be minus 0.2 centimeter. Okay, so this is the error. So this we can add or subtract in the final and we can correct the measurement. So cause is known, so we can correct it also. So this is the meaning of the error due to in this. So this is also systematic error because here cause is known and we can correct it. Okay, so this is a systematic error. This is due to personal mistake. The person is doing the mistake. No, there is no mistake in the scale. In this instrument there is no mistake, but person is taking in the wrong way. Okay, so this is due to personal mistake. That this error we can call it as a systematic personal error. Sometimes it may happen that an instrument is faulty. Means what? Or sometimes it may happen that the instrument is not calibrated properly, or on this scale, scale, whatever this 1, 2, 3, 4 numbers are written, that is rubbed. Okay, and it is not visible properly. So this instrument is faulty, you can say. So small readings, 5.8 is not clear. So somebody have said 5.9 instead of 5.8. Okay, it was 5.8, but something was not written properly. So here I have written 5.9. So that is a instrumental error. So this can be due to faulty instrument. So this is called instrumental error. Systematic but instrumental error, like this. Important thing in this is what? These errors can be predicted because instrument is faulty, so one can predict, yes, this will give you wrong readings. We have to use it carefully. Okay, and if the cause is known, we can correct it also. These errors can be predicted and corrected like this. Another example I can give. Suppose there is a weighing machine, digital weighing machine. Okay, and on this is put on table. Suppose on this I want to measure, suppose 1 kg sugar. I want 1 kg sugar. So what I should do? I should check whether initial readings are 0. Then I will put a pot here and I will pour sugar in this. Okay, and after that reading will change. If it is 100, if the reading is 100 here, okay, then I will stop pouring and I will say this is 1 kg sugar. Correct measurement, no problem. But suppose sometimes it may happen that initially there was 0.50 and now we are putting pot and we are pouring the sugar in this. Okay, if I will pour like this, and if the reading is 1.00, how much sugar I have got? Only half kg, because already it was 0.5. Now you have added half kg. Now 0.5 plus 0.5, we have got 1 kg. Wrong reading. Okay, less sugar you have got. But this can be corrected. Yes, initially it was 0.5. So now you pour up until you will get 1.5. Okay, and then you will get 1 kg sugar. So like this, you can, if the cause is known, you can correct the reading. Okay, so these are the systematic errors. This can be personal, this can be instrumental errors. Okay, and these are corrected. Here important is cause is known, and this can be predicted and corrected. Corrective measure is what? Addition or subtraction. Addition or subtraction of errors. By adding or subtracting, here what I am doing? Here I am adding. The 0.5 I am adding, and then I am getting correct value. If here initially if this is minus 0.5, then I have to add the sugar until I will get only 0.5, not 1 or 1.5, only 0.5. Then I will get 1 kg sugar. So here I am subtracting. So in this way, you can, by this addition or subtraction of error, I will get the true value. I can correct the values, correct the measurement. Okay. Another is, you note down this. Another is random error. Another is what? Random error. Another is what? Random error. Random error. Random error. Okay. Now look. In this type of error, cause of error is not known. Is not known. Cause of error is not known. Okay. Sometimes suddenly atmospheric condition changes, temperature rises. Due to that, suppose there is something like this. This is a scale, and this is the pointer, and something is attached here. Some arrangement is there, and suddenly, and something is flowing here. Okay, and this is a pipe. Suppose water is flowing, and this water goes in this instrument, and here, due to this, some changes in the pointer happens, and you will measure the pressure of this water like this. This is a pressure measuring instrument. Let us assume. Okay, but suppose suddenly temperature rises there, and due to that, little length of this rod is increased. Due to that, what will happen? This will get deflected, and this will give you wrong reading. It was set for this much length, but this length is little increased, so little deflection will be there, so wrong reading you will get. Accidentally this happens. That is why. So how this is how nobody can predict what will happen in future. That is why these errors cannot be predicted, cannot be corrected, and these are called accidental errors. Accidental errors. Accidentally they happens. Something happens. Normally due to change in atmospheric condition. Normally due to change in atmospheric condition, these errors occurs. These errors cannot be predicted nor corrected. So what is the corrective measure for this? How we can correct? You take number of readings more. So corrective measure, in the previous case, in systematic error, what is the corrective measure? Addition or subtraction of error, you will get true value. Here corrective measure is what? Corrective action to minimize random error. Random error is to take more readings. Instead of 10, you take 20, 50 like this. More readings and do averaging. Take average of that. In this way, you can have the measurement close to the true value. Clear? Okay. So I think this much is sufficient for today's lecture. Okay. So in the next lecture, we will see error propagation and we will solve some numericals based on that. Okay. Error in addition, subtraction, multiplication and division. Okay. So till then, you do your study well, note down everything. Subscribe my channel forward to your friends, forward the link to your friends, like, share, subscribe. Write something in comment box. And if you have any suggestion, if you have any concept, if you want to learn, you write in the comment box. Based on that, I will prepare a video. Otherwise, sequentially, I am creating the videos. Okay. So, best of luck. Bye.